Welcome to our 11.7 notes, more about parabolas and their applications. Specifically, we're going to look at the vertex a lot today. Okay? So the first thing we're going to do is, how do we find a vertex if it's in standard form, it's not in the vertex form that we had before? So the first option is using completing the square. I know you guys hadn't used it in a little while and missed it, so we're back doing it today, okay? So completing the square will actually get it in that perfect square format that we want it to be in. If you guys remember from last time, the vertex form looked like this. F of x equals a times x minus h squared plus k. It looked like that. So what we want is this x minus h squared somewhere, and so that's why we're completing the square. So let's do it. So the first one I have is f of x equals x squared plus 4x minus 9. So first thing we're going to do is try to complete the square. So unlike last time with completing the square, you don't really get things away, you just kind of separate them, because we still want just f of x on one side, okay? So I'll have x squared plus 4x plus blank for completing the square, and I'll still have this minus 9 that I still need to deal with, okay? So to complete the square, just a refresher, you take the middle term, which is our 4x. Remember that the x comes from the x squared, so we're just focusing on the 4. Half of 4 is 2, and then you square it. 2 squared is 4. So that's what we add to complete the square. And as hopefully everybody can tell me, you can't just add stuff to one side of the equation and think that it's going to be okay. We need to balance it out. So you can either add 4 to both sides if that makes your brain feel better, but you're going to have to subtract it over at some point. So what I'm going to do is actually subtract 4 to balance it out, because adding 4 and subtracting 4, that's adding a 0 to that side. Then I can factor. So factoring right here, x squared plus 4x plus 4, that's going to factor as x plus 2 squared. So remember that the square root of x squared is x, the square root of 4 is 2, and we keep the same sign as the middle. Okay? Then we can combine some like terms over here. Negative 9 and negative 4 would be negative 13. And ta-da! We are in vertex form. So now we can find the vertex. So the vertex, remember the vertex is hk. So the h for us is the opposite of positive 2. So that would be negative 2. K is exactly the same as the constant at the end. So we have a minus 13. My k value is negative 13. So there's my vertex. It's negative 2, negative 13. Let's do another one. What if I have a coefficient up front? What if I have an a value? You're going to factor it out first, okay? That's what it looks like. And that actually gives you this a. We know what the a is going to be. It's going to be a 2. So let's look at that. If you factor out a 2, that'll be x squared and minus 2x. I'll have a little plus blank for completing the square, and I'm leaving the plus 1 alone. Okay? So let's think about what's going to go in the blank. So half of negative 2 would be negative 1, and negative 1 squared would be negative 1 times negative 1, which is positive 1. Now we do need to balance that out, and the thing is we didn't just add 1 to this side of the equation, did we? We added 2 times 1 to that side of the equation. So we actually added a 2 to the right side. So to balance that out, I'm going to subtract 2. Okay? Then we're ready to factor. So if I factor what's inside the parentheses, that would be an x. We'll have the same sign, which is a minus, and the square root of 1 is 1. So it factors x minus 1 squared. Then we can deal with our like terms over here. I have a plus 1 and a minus 2, and 1 minus 2 is negative 1. Okay? Then to find my vertex is hk, so my h value is the opposite of negative 1, which is positive 1. my k value is the same as what's at the end. So my k value is -1, and there's my vertex. Okay. The other option, which you guys will probably enjoy a lot more, is that there is a formula, okay? You can use a vertex formula. So the vertex formula actually goes back to the quadratic formula. Do you guys remember the quadratic equation? X equals -b plus or minus the square root of b squared minus 4ac all over 2a. And do you remember that the only time that we had only one answer was when the square root was 0? You guys remember that a little bit? Well, if your parabola looks like a U, what's going on is usually there's two different values, right? Well, the only time that you would get only one answer is actually at the vertex. And so when your square root is 0, that is when you have a vertex. My cat's saying hi again. Come on. Come on. There you go. So that's when it happens. So in case you're wondering, the vertex for any quadratic will always be -b over 2a for the x value. Okay, because that would make all of this 0. Okay, so to find a vertex easily, your x value will be the opposite of b over 2a, and then the y value, you just have to plug it back into your equation. That's f of -b over 2a, so you're substituting it back in to find the y value. You ready? Great. I have the exact same problems as example 1, so you guys can really see they both work, okay? But this is a lot faster if you remember it. So just a quick refresher. So we've got f of x equals x squared plus 4x minus 9. Our a value would be 1, our b value is 4, and our c value is -9. So to find the x coordinate, I'm going to do the opposite of b over 2a. So the opposite of +4 is -4. And then I have 2 times a, so 2 times 1 is 2. Then I can divide. -4 divided by 2 is -2. To find the y value, all you've got to do is substitute it back in. Okay? So the y value would be f of -2. You're just going to substitute it back into the equation. So that would be -2 squared plus 4 times -2 minus 9. So let's see, -2 squared is +4. 4 times -2 is -8. And we also have a minus 9. 4 minus 8 is -4. And -4 minus 9 is -13. And putting both of those together to give our vertex, so our vertex for this, the x value is right here, it's -2. And my y value, I just found it, is -13. And you'll notice that's exactly the same thing that we got in part A of example 1. Okay? Let's do another one. So for part B, we're going to use the exact same equation and see if we get the same answer. So I'm actually going to let you guys try one. So see if you can use that formula and find the vertex. You know what the answer is going to be. To check yourself, but go ahead and pause your video, see if you can try it, and I'll show you the answer in 3, 2, 1. Okay, you guys hopefully knew what the answer already was, but the vertex for part B should be 1, -1. You should do x equals the opposite of b, so that would be 4 over 2a, so 2 times 2 is 4, and 4 divided by 4 is 1. For the y value, you should just be plugging in 1. So 1 squared is 1, times 2 is 2, minus 4 times 1 is 4, plus 1. And then you're going to get -1 for your y value. Hopefully that went okay. Let's try some more. So this is how you find the vertex when it's in standard form. Next up, how do you graph an equation if it's in standard form? Okay. So graphing an equation in standard form, it's actually really easy to find your intercepts. So let me show you how to do those, and then we'll talk about graphing. Okay. So for my y-intercept, if you guys remember, y-intercepts happen when x is 0. So then I would have a 0 minus 0 plus 5, right? So that would just be 5. So my y-intercept would be the point 0, 5. And I can plot that right here. Okay? For your x-intercepts, remember that x-intercepts happen when y is 0. So we would make f of x equal to 0 and solve. And you can use any of your methods of solving. I notice that this one factors really easily, so let's factor it. So it factors as x minus 5 and x minus 1, which means that I have two x-intercepts. I have an x-intercept where x minus 5 equals 0, which would be at positive 5, so the point 5, 0. And I also have an x-intercept where x minus 1 equals 0, so I'd add 1 to both sides, and I would get x equals 1, which gives me an x-intercept at 1, 0. So I can also plot those on my graph. I have an x-intercept at 5, 0, and an x-intercept at 1, 0. Okay? So you're noticing I'm getting some nice pretty points here, aren't I? And then, of course, it's always nice to know where your vertex is. So let's find the vertex really quick. So personally, I'm just going to use the formula that we did on the last example. So for my vertex, I'm going to say that the x-coordinate equals negative b over 2a. So for me, that would be the opposite of negative 6, which is positive 6, over 2 times a, and 2 times 1 is 2. 6 divided by 2 would be 3. So my x-coordinate is 3. For my y-coordinate, I will plug it back in. So I'm going to do 3 squared, which is 9. 6 times 3, which is 18. And then I'll also have a plus 5. 9 minus 18 would be negative 9. And negative 9 plus 5 would be negative 4. So what I know is that I have a vertex at 3, negative 4, and I can plot that as well. And at this point, I have a pretty nice looking U. If you would like to make a symmetrical point for that y-intercept, we know that there's an axis of symmetry that goes right through the vertex right here. That y-intercept is 3 away from my dashed line here, so I'm going to have the exact same point 3 away on the other side. So you can make a symmetrical point, okay? And that's plenty of points to make a nice smooth curve. Okay. How's that? Pretty okay? Okay. I'm going to let you guys try some pieces and parts on this one, okay? So in part B, I want you guys to see if you can find the y-intercept. And I want to see if you can find the vertex. We'll talk about the x-intercepts together, okay? So see if you can find the y-intercept and the vertex. Go ahead and pause your video, and I'll tell you the answers in 3, 2, 1. For the y-intercept, it should be the point 0, negative 10. For the vertex, you should get the point negative 2, negative 2. How'd you do? We do okay? Alright, let's talk about the x-intercept really quick. So for the x-intercept, if I have 0 equals negative 2x squared minus 8x minus 10, it doesn't factor nicely. So then the question is, do we even have one? The easiest way to check is looking at your discriminant. So if you guys remember, the discriminant is the b squared minus 4ac that's inside the square root. And for us, b squared would be 64. And then we'd have 4 times negative 2 times negative 10. You're actually going to get a discriminant of negative 16, which means that there's no real x-intercepts. Okay? So looking at the things that I have so far, and I'm about to run out of time, we have a point at negative 2, and a y-intercept at negative 10. You can make a symmetric point over here and go ahead and connect your dots and we'll be good. You notice it does not intersect with the